Hello, everyone, and welcome. Thank you for joining us for our second installment of our Ask the Experts Roundtable series. Today, we're diving into a critical and timely topic for AI infrastructure leaders: mastering AI cloud scale, how precision multi-tenancy unlocks performance and control. I'm Jason Brown, Senior Director of Product Marketing here at DDN, and I'm very excited to be joined by today's experts, James and Atul, as we dive into one of the most critical and often misunderstood aspects of AI infrastructure, which is multi-tenancy. But before we begin, I'd love to have our experts introduce themselves. So, Atul, why don't you start?
Thanks, Jason. Glad to be here. Hi, everyone. I'm Atul Vidwansa. I look after worldwide AI cloud providers for DDN. And almost every day, I do talk to service providers offering GPU as a service, AI as a service, software as a service. And this one topic, which we are discussing today, is close to their hearts. And I keep on getting questions on it. So we thought we might get together with all the experts and make our view of the technology available to all the customers. Glad to be here.
Absolutely. That's why we're here, right? To talk about the stuff that you're talking to your customers about. James, I know you were on the first Ask to be an Expert session, but can you please introduce yourself again as well?
Yeah, I'm James Coomer. I run product management for DDN. So I'm in charge of looking after the roadmap of the various products we have. I talk to engineers, I talk to the internal folks, and I talk to customers. And as Atul says, multi-tenancy is really hot and shared infrastructure is really hot at the moment, but also bound up with an awful lot of confusion for various reasons. So we're hoping to clear all that up today.
Absolutely. And really appreciate both of you jumping on today to help clarify the situation when it comes to multi-tenancy. I've been around in infrastructure for 20 years, and it's definitely evolved since I started. Like Atul said today, with AI cloud providers, these folks were offering, GPU as a service, AI cloud as a service. Obviously there's many, many users trying to connect to a single system. And so multi-tenancy is very, very important. Now, with that said, I think we want to make sure that, we are able to ensure the audience, knows what we're talking about when it comes to multi-tenancy, because there are so many different viewpoints. So, depending on resource contention and performance drops, traditional infrastructure just really wasn't built to handle modern AI demands, especially when it comes to multi-tenancy. Our expert panel here is to unpack exactly what that means, why it matters, and how to do it right. And so let's get into it. First off, as I said before, let's set the stage. Let's, dive in and say, what is multi-tenancy and what does that really mean? So I'd love for one of you to really start with trying to define that so our audience knows, what are we even talking about when we talk about multi-tenancy, about, in today's AI infrastructure?
Well, let me start and then Atul can follow up then. So I just point people to public cloud, their experience in the past many, many years with using the likes of Azure or AWS or GCP. So when you log in there, you create an account and you might create virtual machines, you might create services and run applications, create databases, whatever it might be. So you might have a complete ecosystem in there, but somehow you can't see everybody else that's showing that same infrastructure. Your data is secured from everybody else. You get some kind of performance protection from everybody else. You have your own authentication mechanisms. You can provide your own networks and all this kind of stuff. So it essentially comes down to we are, in fact, using underlying shared networks, shared hardware, shared storage systems, but somehow, through the magic of multi-tenancy, we feel we have a completely isolated system with all the benefits that provides in terms of security and performance and quality of service and even uptime and resilience.
Add a little bit of color to this from a service provider's point of view. As James said, most of these AI service providers will have large clusters of GPUs, CPUs, data storage infrastructure, networking infrastructure, putting all this together. Now, from their point of view, they want to maximize the utilization of this infrastructure. We cannot predict is what kind of customer they would get. They could get customers asking for one GPU. up to thousands of GPU at any point in time. Allocating physically separate resources to each of these customers is, of course, difficult in terms of managing technology, cost prohibitive in terms of actually making sure that this infrastructure is utilized. And as a result, all service providers would look at how do I make sure that I can have multiple users on this system, maximizing utilization of my infrastructure.
Yeah, I think you both have nailed it there, right? Shared resources from a single system. Uh, and that means, many different things, but at the high macro level, that's really what multi-tenancy is about. Now, when you start to dive into multi-tenancy, there's a lot of terminology that kind of pops up and can be a little confusing as well. So I'd love to get some help from both of you in regards to some of the common terms that I hear when I look at multi-tenancy, such as tenants, subtenants, quality of service. What are these things? Atul, why don't you give us your perspective on what these things are first and foremost?
Sure. Um, so with the new cloud-enabled world, what is happening is most of the large organizations are going on to the public cloud or even on a private cloud for all of their IT needs. So what we see in real life is customer signs up for this private or a public cloud, and then multiple departments within the customer's organization want to use the same IT infrastructure. A good example would be, let's say, an enterprise customers having their HR, finance, supply chain, all these departments working together, but at the same time, they want to have some kind of isolation, because remember, not all data is available to everyone in the organizations. So what they look at is, if we go on a cloud infrastructure, how do we make sure that the individual business units within the customer's organization can effectively use that infrastructure? At the same time, they are isolated from each other. Okay. This kind of usage then gets translated into what we call multi-tenant usage. Okay. Where each organization becomes tenant of the cloud, and each of the department within that organization becomes a subtenant. So that's the most typical way in which you would see customers using a multi-tenant cloud infrastructure.
Got it. So tenants and subtenants are just ways to carve up the infrastructure for a certain business. Because as you said, right, you could have a company that pays a bunch of money to a cloud provider and says, I want to use this. I want to maximize my usage, but I have all these different departments, right? And I don't want finance looking at HR data and vice versa. So these tenants and subtenants are ways to really carve that up. I'll say virtually, right? Or is it physically? You tell me, to be able to utilize that cluster, but also to ensure their data is separate.
Yeah, so imagine you're an AI service cloud provider, and there are many right now, some of them extremely large, and as Atul shares, they're very diverse customer sets. And from the customer's perspective, what they are looking for is the easy button to AI. They don't want to buy infrastructure, create data shareables, all of this kind of stuff. They just want to log in with all their colleagues, bring their data on board, and train their models or run their inference models or prepare their data, all these different areas. And they might also be interacting with other cloud environments or on-prem environments at the same time. So from a customer's perspective, it's ease of use, time to productivity. And when they're in there, of course, they want to see the same things as everybody else. Value for money, great efficiency, good GPU productivity for every GPU hour that they pay for. They want to see good productive output from that. From the cloud provider's perspective, though, who are often our customers, they want to deliver these things, obviously, to their customers, because then their customers will come back for more and expand and be happy and give them more revenue. But also at the same time, they also want to make sure, and Atul touched on this, is make sure that they make the most of the hardware that they're paying for. They've got a data center for their cooling, all this kind of stuff. So they have another thought in mind is let's maximize, whilst maximizing our individual customers, tenants, happiness, and business value that they receive from the offering, we also want to maximize the revenue from the cloud infrastructure, from all the hardware, the networks, the GPUs, the data center, the cooling that they've invested hugely in. And I mentioned this quite carefully because it's where we feel that most approaches to multi-tenancy actually fail. Everything looks the same on the internet, right? So every marketing play looks like everybody's got it and it's all great. And until you dive into the details, you don't really see the business value of good versus bad. So this is why we were saying at the start, it's very confusing for people. Everyone's got a great pitch, but actually what's underneath that, or what really are the consequences of implementing in a certain way with this multi-tenancy? Because effectively, fundamentally, you are dividing up your infrastructure in some way. And you can imagine it on several levels. You can divide it up physically, which people have done in the past. They've built a separate cluster for every customer. And so, everybody's happy apart from the infrastructure provider who has a very hard time managing this hardware. Secondly, you can divide it up at some logical layer. And this is what everybody does today. Now, the problem is in that logical layer, there's a good ways and bad ways of doing it. And really, if the logical layer is really deep, really native, really understood by underlying software, then it can sort of reap huge dividends for everyone involved. So this concept of true native multi-tenancy is something that we believe in at DDN, and we also believe that nobody else has done it yet. So this is why this is an interesting talk today. We want to try and dissect what it means to have true native multi-tenancy and point out a few of the flaws in, let's say, retro implementation of multi-tenancy that we've seen in every other competing storage solution.
Yeah, that was a great lead into the next question I had, actually, because you talked about the business outcomes that these organizations want to get from from building this AI cloud provider or public cloud provider business, right? Obviously, the goal is to be able to make money and have revenue. And when you have hundreds, thousands of users trying to access the system, you cannot survive without multi-tenancy. So obviously there are a lot of challenges that these organizations face when it comes to multi-tenancy. And we ran a LinkedIn poll asking the audience, what is your biggest challenge in managing multi-tenant AI workloads today? And we provided, a few, obviously, multiple choice answers. And the first challenge, the biggest response at about 60% was power and simplicity at scale. So I'd love to get your thoughts on that first one, right? 60% of the audience, so obviously a majority of the audience, say that their biggest challenge in managing multi-tenant AI workloads is power and simplicity at scale, which, I can understand each of them individually, but how do they come together to be that singular answer and biggest challenge when it comes to multi-tenancy today? Love for one of you to take that one.
One aspect of it, which is the simplicity, right? Now think of a very small unit of any resource, right? Think of, let's say, as one CPU, right? Let's say CPU that has about maybe 32 computing cores, right? At the simplest level, you could think that, okay, I can assign one core to one tenant and I can run up to 32 tenants on the system time, right? Beyond that, I will require very simple. But now think about this, that most of the customers want their workload to be elastic, to be scalable. Okay. Doing this at thousands of CPUs or GPUs or customers, it becomes very, very difficult not only assign resources, but to guarantee them performance on that resource. Okay. And this leads to a very important requirement in multi-tenancy, which we call quality of service. Okay. Ultimately, if you have multiple users on the same system, what will happen is what we call a blender effect. Right? You have everybody competing for almost same resource. Now, when customers sign up, okay, they expect that, oh, I will get to utilize 100% of the resource that I'm paying for. Okay. How do we make sure that they actually get that utilization? Okay. So avoid this blender effect. Most of the multi-tenant implementations, the first thing they need to do is to make sure they can provide quality of service at a smaller scale as well as at a very large scale. Okay. Now, when you talk about simplicity, managing that quality of service, both on a service provider side and on a customer side, the experience of quality of service. I mean, delivering this is very, very difficult. And when you design a product that you think has to be multi-tenant, you have to put this design, this requirement at the initial stages of putting together your software, hardware, equipment. Okay. You can't add multi-tenancy, you can't add quality of service to something that wasn't designed for it. And we do see of a lot of products available in the market trying to meet these kind of requirements in a very ad hoc fashion. Okay. But we realize, and I'm sure James will touch base on it, we realize that this is something that has to be designed it into the product. And that's where some of our recent innovations that have come out to the market have been used at a very, very large scale. Okay. They are tailored at making sure in a very simple to manage way, we can provide quality of service to large set of customers in a multi-tenant environment.
Yeah, agreed. Now, James, before you comment on that, I'd love to just take a step back because we talked about that terminology a minute ago and quality of service didn't come up. So, James, why don't you give a quick definition to the folks here before we jump back into the poll about quality of service? What does that even mean?
Again, it is a source of confusion because everybody's kind of washed it with their own desired definition depending on the limitations of their own software approach. But I'd say that quality of service is part of a set of SLAs that we want to provide to our customers as part of our business solutions. And so the SLAs we have, they pertain to both performance. So how much performance can I be guaranteed? What is my resilience? What is my security SLA? Uptime SLAs, people will be familiar with these. Now, quality of service is a performance SLA. And as I said, there is confusion because people use the term quality of service, and in fact, all our competitors use a quality of service when they actually mean a performance cap. And a performance cap is a maximum limit. It's a limit. So the easy way to do quality of service is to put in a limitation on the maximum IOPS, the maximum bandwidth, which is actually, if you think about it carefully, what nobody really wants. The service provider doesn't want it because it means their system's going to be underutilized. The user doesn't want it because what they really want is a minimum service level, right? They want to know that their latency is not going to drop below a certain point. Their bandwidth and IOPS are not going to drop below a certain value. It's nice to have a cap for some reasons, but really the hard thing, and I think people really want, is a service level guarantee of the minimum performance that they're going to be offered. And this is what we see isn't actually provided by anybody out there apart from DDN today, because it's very, very hard to do, and it requires an awful lot of sophistication in the platform. So that's what we've done. We've built in natively into the key space of our underlying data structures the concept of the tenants, and that allows us to deliver these SLAs like nobody else, deliver minimum levels of performance, and do so dynamically. So imagine again, you provide a quality of service level for performance for a particular tenant, and they're bubbling along and they're consuming their performance within their boundaries. even though there are other neighbors which are potentially competing with them, but this quality of service is defending the allocation they've been given. So this is what happens with DDN. You allocate a performance to a certain tenant, and they will be able to expand out of that if there's resources free, but they won't be squashed below that certain level if there's competition for resources, which is great. Now, it might happen that on a Friday, there's some really tough work that needs to be done and they want more performance, and they'll pay for that, right? Some burst performance, let's say, or a higher tier of performance. With DDN, we can provide that. So we can just use the API, say, let's up this tenant from medium to high priority for 3 hours. And they can go ahead and do that. And then the SLAs will be expanded. That tenant will experience higher levels of performance, and all is good. These are examples of things that you might imagine are available elsewhere, but are not. Other systems are not dynamic. They do not provide proper SLAs in terms of minimum performance levels, and they're not simple to use. And the simplicity for the end user, as you saw in the original part of the question, really turns into deep sophistication for the software. And we've done that hard work. We've done the hard work in the deep sophistication on the software side, so that the end user or the service provider experiences huge amounts of simplicity. Just an API call, tenant A, move from medium to high performance now. And that's all it takes with DDN, because it's a true native implementation of multi-tenancy.
I love how you tie that all together, and way to come full circle again. Appreciate that. Makes my job a lot easier here for this roundtable. But I love how you said minimum instead of maximum when it comes to quality of service. People think about it usually, like you said, we have a ceiling. We can't go above that ceiling. But what about the floor, right? The floor is important, because if you have the floor defined, then you can go to that ceiling, or there even is no ceiling, right? Excuse me. And so I love how you talked about that when you talked about quality of service, and that quality of service really does help with the simplicity.
Yeah, it's funny, isn't it? Because it feels right. If somebody says, oh, my software can give you can say 10 gigabytes a second for this tenant and 100,000 IOPS, it feels like the right thing. But when you think about it a bit more carefully, it's the opposite of what you want. You don't want this maximum. You want a guaranteed minimum performance level to keep your business running as per your requirements.
Definitely. So going back to that poll, and just to remind the audience, the poll that we asked on LinkedIn was, what is your biggest challenge in managing multi-tenant AI workloads today? The first and majority of the answers, as I said, at 60%, were power and simplicity at scale. What followed that was something very similar, operational complexity. And I actually could probably lump simplicity and complexity together, right? Because you've got kind of, the problem A, problem B, right? We want simplicity, but things are complex, right? And so I can see now about 80% of the poll respondents really talked about this simplicity at scale due to the complexity of managing these very large environments. As the tool said, right? You could have hundreds, thousands of users. You could have hundreds, thousands, tens of thousands of tenants as well, right? So you can imagine, as things begin to scale, and here at DDN, we're very familiar with challenges at scale. We have been doing this for over 20 years, and we have some customers that have, an exabyte of DDN installed in their environments, right? So we know that at scale, things can get very complex. So having this automation, the quality of service controls to make things easier for not only your end users and customers, but for the folks in IT that are managing these systems is super important. Now, one of the other poll answers, the last 20% of the respondents said that their biggest challenge was lack of visibility into usage. So this kind of goes back to those IT folks I just mentioned. What if you're managing, and I guess it comes for the customer as well. If you're either managing or using this very large AI cloud provider environment, what kind of statistics, what type of usage things are you trying to be aware of as both an IT person of the provider as well as a customer? So, it's two different questions, but similar question, but two different points of view. So, Atul, you're talking to the AI cloud providers a lot. What do they want in a large scale, environment, that when it comes to this visibility question?
a lot of times I keep coming across these kind of questions where customers of these multi-tenant environments they raise support tickets and with a very ambiguous wording, and it could be as simple as my application used to run in 2 hours till yesterday, and today it's taking 4 hours. What's happening, guys? I want to know. I can't sustain this kind of response from a cloud infrastructure. If it can run in 2 hours, I want it to run in 2 hours. Okay, and from that simplistic 2 4 sentence support ticket, the cloud service provider needs to figure out, okay, was that application really taking 2 hours for the last, let's say, a week or a month or a quarter? And is it really taking more than that? And then dive deeper into the perceived issues, like why it's taking so much time. And this is where the observability piece, the monitoring piece, the health statistics, performance statistics, all of this now needs to be looked at in order to solve a simple 4 sentence problem. Okay, and we see quite often when I looked at the poll results, I believe this is what most of the respondents are saying, that on a 1,000 tenant environment or a 10,000 tenant environment, okay, not only this is difficult to figure out what's happening with each of the tenant, okay, but an implication of even 50% of them complaining at any point in time becomes very difficult for cloud service provider to support, right? Remember, nobody's going to staff their support department with 50,000 people if they see these kind of issues. Okay, so this is where I think, again, built-in multi-tenancy, built-in user statistics per tenant. It's not something that you enable when a tenant or a customer asks for it. This is something that has to be there in the product, has to be there for a user to look at for their own resources, for a system administrator to look at from a overall system perspective, and somebody who actually decides how much to charge for it, they also need to look at it. Okay, so all these aspects finally point to, okay, how do we make sure that at a very large tenant level, we can see how each of them are using the system? Are they getting the SLAs they have signed up for? Okay, and if they are not, what needs to be done? So this is what most of my customers are telling me with respect to visibility into, let's say, the resource health, resource performance, all of such statistics.
Yeah, that was a great perspective from the AI cloud provider, the folks running the systems. So James, on the flip side, if I'm a customer using one of these very large AI cloud providers or even a public cloud provider, what kind of statistics visibility do I kind of want, from my perspective that the cloud provider can give me? Because there's obviously tons of statistics, as Atul mentioned, and depending on, your IT problems, your concerns, your expected, performance, things like that. There's many different statistics you might want to care about. So kind of what statistics from a customer side do you think are super important when it comes to utilizing these new, as a service providers in the AI space?
Yeah, I mean, as Atul put it, it's very simple to state the question from an end user's point of view. My application seems to be running slowly. Why? But it's incredibly difficult to find the answer very often. Um, and part of the reason it's difficult to find the answer is because most platforms can't tell you. They're not able, fundamentally, to see the application. All they see is stuff happening, and they don't know it's anonymous stuff. We're getting bits and bytes raining down on us, requests for this, requests for that. And as a data platform, you don't necessarily know who's doing it, what's doing it, which application, which tenant, which user. And that's the norm for pretty much every storage vendor out there, apart from DDN. And we've been doing this now for probably over 10 years, is having deep workload insight. Again, this is kind of unique. So we can see the workloads as they're running in real time as a data platform. Now that's great for the end user because they can see if their application is doing things which they hadn't expected. Is it for some reason performing way more operations of a certain type than it does normally? Or are the operations taking an awful lot of time? And so you're spending a lot of time in checkpointing on platform A and spending less time in checkpointing on platform B, and that's improving the application performance by a factor of 2x. A very common kind of challenge we see out there when customers are running in public cloud environments without DDN is their checkpoint performance is poor. As again, it's almost invisible normally. There's just this application slowness, and it's difficult to pinpoint the actual fact as the data platform is responsible for much of that inefficiency. So we call it workload analysis. Most storage systems, none of them, I think, have that apart from DDN. They can see live real-time statistics of how the application is behaving with respect to the data platform.
Interesting. I like that they can see that. You may have said this, and I apologize if you did, but how granular is that visibility into that tenant level usage? Can you track it by user, by team, or by even a data set? We've talked about how native multi-tenancy is important, and if you build it from the beginning, you're able to provide a lot of information as well as performance for these customers. But if we're looking into some of these challenges, these problems, this 407 support ticket that Atul mentioned, how granular can you get into this visibility?
We actually record the ultimate granularity. So down to the individual application, individual user, can't get more fine-grained than that. And then within that, down to the specific POSIX IO call that's actually being made. Is it a file create? Is it a stat? Is it a directory create? Whatever it might be, we record every single one of them.
The deeper you can go, the more detailed you can get. So, that makes a lot of sense to me that you want to provide these things. Now, does everyone provide these things, or is DDN unique in this area?
Literally unique. It's very hard to do this stuff. Again, it's like one of those things you've got to think about really at the start. It's very difficult to retrofit. So anybody that does NFS or NFS-like play can't do this because an NFS essentially anonymizes the applications. So we've built this in. It is very sophisticated. So there's a lot of complexity on our behalf, but we've built it in so that it's simple on the end user's behalf. The end user will just bring up a GUI and they'll see the operations in real time from their applications as they're running, and they'll be able to see a history after the jobs are finished about what the applications behaved. And this is quite cool, actually. It's maybe a link to a possible next question. But imagine we can see all these workloads and their behavior for every single tenant and subtenant. And by the way, others don't really have the concept of subtenants. So we might come back to that. If after 6 months, we can see all this history about how the system or platform was consumed with respect to GPU, with respect to network, with respect to data, then we can tune the system, optimize it to provide much better value to that customer for the next 6 months or the next year. Because we can say, oh, you actually tried to exceed the boundaries of capability on this particular area. It might be network bandwidth, it might be IOPS, it might be file create, or whatever it is. So we're going to change the service for you and basically give you more back in terms of application productivity for your dollar than you had last 6 months or last year. And it's something that nobody else can do. So this ongoing performance optimization improvement is only possible if you can see what's going on and nobody else can see what's going on.
Yeah, that did lead into the next question that we got from the audience around performance allocation and SLAs, because there's going to be a time when, one tenant is going to start over-consuming resources or maybe breach some SLA or policy limit. And it happens because you change one line of code, right, in an application, and it was accidental, but all of a sudden you see this spike, or people, undersize, and not on purpose, but just because they just, are so new to AI and these applications and these users that maybe they didn't expect that, we're going to have 50 people using this as opposed to 2 people, right? And so things just happen. So having that automation built in and the ability to fine tune on the fly at scale, to me, not being a super technical person, sounds very, very important, and something that I feel any of these AI cloud providers or cloud services, or even a very large organization that's running an AI factory. It's the same thing, right? When we talk about multi-tenancy, they're going to have multiple departments: HR, finance, accounting, engineering, marketing, right? That are going to need to access this on-premises AI factory or system that's very large. So, multi-tenancy, while we're talking in the sense of cloud providers and maybe the call public or hybrid cloud, even, the folks that have their private cloud or on-prem environments, if you're a very large organization, multi-tenancy is just as important for them as well, right?
Oh, yes. I've got a great answer for this one, Atul. I'm sure you do too. So imagine you're a tenant in a shared service. You don't know this, but the next tenant's just signed up, and the next tenant's in financial services. Now, a little secret to people out there: even though these financial service companies are very competent in what they do, often they've got algorithmic developers who might make a crazy thing happen really quickly, and they might maybe create millions of files in one directory. You don't know about this, but somehow it impacts you. This script comes along, and the neighboring tenant, which you have no visibility of, and suddenly all your applications go slow. You've got no idea why. And it turns out it's because the neighboring individual has created this script that does something crazy in the file system, and it squeezes everything else out. So this noisy neighbor problem is fairly well known, but it's particularly problematic in AI clouds, because we do have these rapidly developing applications with individuals who might not have full expertise in how to manage their I/O behavior for parallel applications, right? And you've got no control of that whatsoever. So it's a very, very real problem. It happens all the time, and it's only happening increasingly over time. And the challenge is that most storage environments, or everyone that I've looked at, wouldn't actually stop it from this noisy neighbor from affecting you, even when they talk about their wonderful multi-tenancy and quality of service, because they're not actually applying their performance management on metadata, or they're not doing it properly on IOPS, or there's a back-end problem, not a front-end problem. We can't get into the sophisticated details, but most applications of quality of service, the marketing material looks like this. Reality could be kind of in the bin in terms of, the actual impact on the applications. It can be really bad because they haven't actually got a fully native quality of service implementation. So within Vinia, you might be predicting this answer, but we've done this properly. So regardless of whether the challenge in the noisy neighbor is a metadata one, an IOPS one, a throughput one, a single-threaded one, a stat problem, whatever it is, we're handling it. We've got counters in multiple areas of the architecture, which are in real time being measured and reducing the performance consumption of the noisy neighbor into their boundaries. So keeping them within their boundaries and keeping your boundaries separated from their boundaries with respect to performance. Extremely sophisticated, as I say. The only way you can actually do it is by implementing truly native quality of service, which is what we've done.
Yep. I want to highlight a slightly different aspect with respect to AI service providers. Let me give you an example. You might remember a couple of months back, we had this wonderful Ghibli-based images becoming suddenly famous overnight, where people could go on to an AI cloud provider's portal, upload a photo, and create an animated image of exactly that photo, right? And became so popular that at one point, I believe this service was provided by OpenAI, and the OpenAI founder had to kind of announce that to the world, essentially, that, guys, can you please slow down? We have GPU servers melting in our data center. So what I essentially want to say is that on a typical CPU-based traditional cloud environment, the way to identify the next set of workload was defined. There was enough knowledge to figure out how much this service would scale, how many tenants I would get at any point in time. You could actually plan for it, okay, with a for an AI-based cloud service provider, what we see this, one or the other service goes viral and they get this hundreds of thousands and sometimes even millions of users logging onto these systems, especially in case of inference. And we have seen this again and again that with AI cloud service providers, multi-tenancy on inference is very, very critical because they can't predict which of their services would go viral. And when I'm supporting, let's say, million users today, tomorrow morning, 9 a.m., I would have to support 10 million users. These kind of scenarios are happening more often. And what it resulted in is the traditional notion of multi-tenancy, okay, it doesn't work for these kind of scenarios. Okay, it needs something, especially for inference. And maybe, James, I can ask you that what can be done for inference workloads where you have hundreds, thousands user could log in to avail your service, and all of them either has to be treated as an individual tenant or a subtenant. How can we make sure we support these kind of service requirements?
It is a challenge, you're right, because in inference, then it's actually the opposite of what many storage environments have been exposed to, and even many large-scale environments, is that it's not a grand challenge where you got one application doing one big thing, particularly like training a large language model. Every GPU is running in sync with one big user, one power user consuming an entire system. This is the opposite. You've got, maybe 1 million users or more running against this system. And the only way you can protect the quality of service, absolutely, no questions about it, is if you've thought about that from day one as you're building your core data structures of your data environment. There's no other way you're going to crack that problem. And so firstly, you've got to be able to measure this stuff at a sub-millisecond level, and you've got to react to it in a sub-millisecond level. And imagine an inference query, typically they're going to take around a second, hopefully sometimes less for some automated queries. For some ChatGPT stuff, it might be a few seconds. But we're talking about response times overall, and behind that there's a big workflow of a second or so. So our multi-tenancy has got to be A, handling thousands and thousands of thousands of concurrent users, and B, reacting to that quality of service challenge at sub-millisecond level. And as I say, the only way you can do it is by having a true native implementation. There's absolutely no way any of these legacy or even more modern environments can handle this kind of challenge.
Yeah, definitely agree with all of that. This is a very lively discussion, and I love it. But what is even better is that I've heard that we may have a demo on multi-tenancy that utilizes DDN and Infinia. So you may have heard James say Infinia a couple times. DDN Infinia is our end-to-end AI platform. It's a KV store, that's got native multi-tenancy built into it. James, can you just give us a quick little overview of this demo to really show the audience how we at DDN handle multi-tenancy?
Yep, we've got a data platform called Infinia, runs in public cloud, AI clouds, cloud providers, as we've been talking about mainly today, and on-prem. It provides a full data platform for running AI inference, data preparation, and training. Now, all these things we've been talking about and talking around are built into this Infinia platform. And to prove the nature of it, we've got a demo. And the demo shows us essentially adding tenants with different priorities and seeing those priorities being in real time defended so that the individual applications get the performance allocation they were given. Now, note what I said at the start here is that these are minimum performance level guarantees, so that we're going to protect tenants from going below a certain amount, and we're also not going to reduce the efficiency of the whole system. Two critical challenges which I don't believe that any other provider can solve. So maximum efficiency. If a tenant is the only tenant on a system, they can go and consume a lot more, right? They consume the entire system. But as we add tenants and as competition comes in, people get squeezed down to within their SLA boundaries. We're going to see this real-time action, and we're also going to note the fact that it is super simple. Again, that poll question we had at the start was, for operation complexity, how hard is it? Well, we're not going to go and create some service container, create some VIPs, bind to some tenants and blah, 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 blah. We're just going to use an API, one API call, and we're going to add a tenant with a certain quality of service, and we can change it within a microsecond, within a millisecond or so. I'm going to see reactions happening instantaneously. And here we go. This demo will take you through the creation of a number of tenants on DDN's Infinia platform and will demonstrate automated quality of service, allocating performance to tenants in real time. So what we're doing now is we've logged into the graphical user interface and we're just creating a third tenant to the system before we start running real workloads. We're using the GUI right now, but we could equally be using the API or the command line. And once we've completed the creation of this third tenant, we should see we have 3 tenants in existence, and each one of them has a different performance allocation. This is using Infinia's fair share, which means that different tenants will see the relative share of the performance of the system that they've been allocated. And you'll see we've got tenant 1, tenant 2, and tenant 3 with high, low, and medium performance allocation. So tenant 1 should get more performance than tenant 2, and tenant 2 should get more performance than tenant 3. Now let's switch views. We're looking at Grafana. We're monitoring real workloads. And if we look at that box on the top right hand, then we'll see the S3 user activity from the various tenants, and tenant 1 is starting its workload. There's no competition right now, so it can get all of the performance of the system. When tenant 2 starts up, we'll see the performance now has to be allocated between the 2 tenants. And finally, when tenant 3 starts, then the performance has to be allocated between all 3. Now, the really tough thing is to allocate them in proportion to our allocation. We've given them high, medium, and low. And what we'll see, as the 3 tenants compete for resource, that Infinia is automatically defending the allocation that we provided at the start of this demo, in that tenant 1 is getting the most performance, tenant 2 is getting less performance, and tenant 3 is getting less performance. And also, they're not interrupting each other. They're not affecting each other's behavior. So what we're seeing right now is a steady state activity of all 3 tenants competing, but Infinia is defending the allocation completely automatically and completely hands-free for the administrator. This allows you to have different tiers for different users. This allows you to guarantee particular levels of performance for particular applications or tenants at a particular time. You can change this dynamically. And also, we're not wasting resources. So we can have full system performance when these tenants are all running. And you can see that when tenants finish, the other tenants, the remaining tenants, get to consume the whole resource. So we're not leaving resources on the table and wasting our data center money, our GPU capital costs aren't being wasted just because there's nobody using the system. The remaining tenants can consume all of the resource. And here we see tenant 2 is finishing. And tenant 1 is finishing, and tenant 2 can get all the resource until it finally completes as well. So entirely automatically applying the performance allocations, and the administrator has had to do absolutely nothing apart from apply those allocations on day 1.
That was awesome. I love that. Obviously, we love to show and tell, and if we can show and not just tell, that's phenomenal. So I appreciate, James, you and the team for putting that together and providing that demo on multi-tenancy with DDN Infinia. So we're almost about to wrap it up, but we love live questions. We actually got one from the audience. So we'll just do one because we're running a little long here. But the question was, after seeing that demo, and it is actually not necessarily a multi-tenancy question, but we're okay with that. The question that came from the audience was, what APIs and integration points does Infinia provide for custom application development? So not quite a multi-tenancy question, but that's okay. James, why don't you take?
Cool question, though. Yeah, just to step back for everybody else's benefit, then usually what you do is when you're running against a data platform providing a file system or an S3 or whatever, your choices as an end user are to use the API. You can create some files or delete some files, and you can change permissions or whatever. Now with DDN, we've created an SDK. So this is a set of APIs with various bindings for various software programming languages, which you can write to if you want to, in order to build in application intelligence into your AI world. Now, what does that mean? That means the applications can suddenly do a plethora of additional things and see more things around the environment than they were able to do before, and therefore become more intelligent. So, for example, just give one little example. We've provided the ability to access the metadata associated with the data through SQL-like APIs, so you can have additional methods, more efficient methods of accessing the metadata across a very large system. We've also provided APIs which give you cleaner, more efficient data paths for common operations, and that allows you, if you're running at scale and you've got a challenge, try us out, because we might be able to bypass that bottleneck you've been experiencing with the standard APIs, S3, file system, POSIX, and give you a much cleaner, faster, parallel, secure, compressed, data-reduced data path directly into resilience and the data side. And it's much richer. So A, more efficient, and B, we've got a much richer set of APIs that allow you to build application intelligence.
Not a multi-tenancy question, but appreciate the answer and appreciate the interest from the question asker as well about Infinia. And of course, you can go to our website at ddn.com and learn more about Infinia, as well as our other products and our data intelligence platform and all of those great things. So that is all the time we have for today for our Ask the Experts Roundtable. I want to give a sincere thank you to both James and Atul for sharing their knowledge with us today. And, obviously we hope you liked it. Please provide feedback to us so we can tailor the next one based on the things you want to hear about. So thank you very much, everyone, and have a great day.